Today's topic is Gunn diode. The Gunn diode follows the RWH theory, which is Ridley-Hudson theory. So we know that we have a valence band and conduction band. Above the conduction band at the side, we have another band called satellite band. The forbidden energy gap between valence band and conduction band is Eg is 1.43 electron volt, while the difference between conduction band and satellite band is we add a 0.36 eV, which is 1.79 eV. So the energy increases as we go to the upper bands, but the mobility reduces because here mass increases. So this is the region where it increases and then it becomes constant since mobility reduces, since the mobility increases, and then again slowly increases and comes to nearly the PN junction diode forward bias characteristics. The mass in satellite band is nearly 17.6 times higher than the mass in conduction band. So Gunn diode, it is a microwave semiconductor diode where the frequency is from 300 megahertz to 300 gigahertz. The wavelength is from 1 meter to 1 millimeter. It produces microwave oscillations. It belongs to transferred electron devices, TED, which means a semiconductor device or diode that depends on the internal negative resistance caused by transferred electron in gallium arsenide at high energy. So it follows differential mobility. So this is the structure. We have one side cathode, the other side anode. In between we have this N, and it is supported by both sides N++, which means heavily doped N+ region. And then we have gold plated wires here, and then vacuum tube for protection. So it's a bulk device, a bulk semiconductor made of N or P type of semiconductor. So we have two terminals here, cathode and anode. Lightly doped N region has this region, the center region. It has a size of 120 cross 100 cross 75 micrometer cube. The outer layers are connected to anode and cathode through the leads. It is properly sealed. So non-uniformities and doping are there. So now we have a region called space charge region or accumulation region. So if the voltage applied E is greater than the threshold voltage ET, the velocity of leaving the space charge accumulation is lower than the emitting the electron. So this is the Gunn diode structure where we have a motion of domain. One side we have cathode, the other side we have anode. So as we give a voltage here, the voltage is very high voltage, greater than 3 kilovolt per centimeter. So the electrons travel from cathode to anode slowly. So this it moves slowly and gets accumulated also. Since it's a large region, it gets accumulated in this place and it becomes a larger mass. And finally, when it comes to the anode, it collapses there. So we have some modes of operation of Gunn. This layer is called space charge accumulation layer. So when E is greater than the threshold voltage of ET, velocity of leaving the space charge region is lower than the entering in the domain. The modes of operation of Gunn diode are stable domain mode, where the applied voltage is greater than the threshold voltage. And then resonant Gunn mode or AC transit time mode. The transit time with which the domain travels to anode is called that mode. To get oscillation, we use resonant circuit. Here resonant time corresponds to the transit time. Delayed mode, the transit time is greater than the frequency of oscillation. And then limited quench domain mode, transit time is less than the resonant time. Limited space charge accumulation, LSA mode. So it's more popular and efficient. So the frequency of operation is extremely high so that there is no mass formation in the domain. Diode is kept negative conductance, so simplest form of operation. So automatically the electrons keep on moving from cathode to anode and there is no domain formation. So the performance of Gunn diode. Gunn diode oscillators work in LSA mode, limiter space charge accumulation mode generally, to produce oscillation greater than 6 kilowatt and 1.75 gigahertz. This pulse power is reduced to 400 watt at 50 gigahertz. Efficiency in LSA mode is nearly 20%. Continuous wave power at 40 gigahertz is 10 micromilliwave. So problem Gunn diode, as with other two terminal devices, it produces isolation between the input and output sections. So application producing amplification and oscillation at microwave. Gunn diode is used to amplify signals from 4 to 150 with voltage rating of 6 to 12 dB. So this is regarding Gunn diode. Thank you.